Okay, let's dive into this because today we are looking at something that honestly feels straight out of a sci-fi novel, but it's not. This is an actual finalized engineering and architectural blueprint for the 2055 epoch. We're exploring the Cryogenic Global Compute Hub. This is a planetary-scale megastructure designed not just to solve a monumental energy crisis, but to act as an immortal, self-healing vault for human knowledge, situated in literally the most hostile environment on Earth, the East Antarctic Plateau. It's an absolutely mind-bending piece of engineering, and I am so excited to explore it with you today. To really wrap our heads around this megastructure, we need to take a strict zoom-out approach. So here's our roadmap for this explainer. We'll start big with the AI energy crisis, zoom way down to the microscopic Arctic compute block, scale back up to the macroscopic triple brain topology, check out the nuclear power and laser mesh, look at the logistics of airships and robot hives, and finally bring it all together with the black box of civilization. Section 1. The AI energy crisis. So why go to the absolute ends of the Earth to build this thing in the first place? Well, by 2055, humanity is facing some serious, civilization-threatening stakes. Just look at this number, 10,835 terawatt-hours. According to the blueprint, that is the projected annual electricity demand just for computation by the year 2055. Between our insatiable drive for real-time AI agents and planetary-scale climate simulations, we are creating a massive, existential global bottleneck. Our current infrastructure, it literally cannot handle this load. And this brilliantly illustrates exactly why. The thermodynamics here are fascinating. Traditional data centers in temperate climates are just fundamentally broken for this scale of demand. They typically run a power usage effectiveness, or PUE, of 1.5 to 1.7. What that actually means is up to 50% of their total power consumption is being wasted entirely on just cooling the air. The radical solution? You drop an open-air monolith into the deepest passive thermal sink on the planet, the East Antarctic Plateau. Out there, absolutely 0% of your power is spent on mechanical cooling. Section 2, the Arctic compute block. Now, to pull off that zero cooling miracle, engineers had to shift focus from the massive global crisis down to the microscopic unit of survival, the foundational building block of the hub itself. Enter the Arctic compute block, or the ACB. You can completely forget about traditional server layouts with distinct motherboards and separate storage drives. They threw all that out. Instead, the ACB fuses the CPU, memory, storage, and networking into a single, standardized, sealed, solid-state brick. So yeah, upgrading your RAM is definitely not happening here. And to make sure heat distributes perfectly, the whole internal cavity is hermetically sealed and backfilled with helium. Helium acts as this incredible thermal bridge, way better than air. The specs on these things are just mind-bending. A single block weighs an incredible 2,420 pounds, is 90 inches long, and draws a massive 864 kilowatts of power to push 82 exaflops of processing and hold 128 exabytes of raw storage. But here is the most important takeaway. Because of that passive cooling design, 99.8% of that massive 864 kilowatt input becomes pure computational work. A block this incredibly powerful emits remarkably low waste heat. We're talking just 1,850 watts. Now, you can't just stick normal electronics in a deep freeze and hope for the best. Everyday structural metals will undergo a ductile to brittle transition at minus 100 degrees Celsius. Literally, they would just shatter. So the engineers brilliantly chose 5083 marine-grade aluminum for the casing because, believe it or not, it actually increases in tensile strength in extreme cold. Plus, it gives you immense thermal conductivity for the internal dual-plane silicon surfboard architecture, where the computing arrays are epoxied directly to the floor and ceiling of the block. Section 3, the macroscopic triple brain. Okay, we've seen the 2,420-pound single block. Now let's zoom way out to the macroscopic topology to understand the sheer scale of 18,000 blocks spread across the ice. 21.49 yottabytes. Just let that sink in for a second. The entire setup is divided into 3 separate, geographically isolated 6,000 block farms, which they refer to as brains. They use these incredibly aggressive 35x neural compression algorithms right at ingestion, combined with a 5x erasure coding protocol across the 3 farms. The result? It transforms these arrays into a 21.49 yottabyte, triple redundant, immortal global storage vault. It's enough to securely hold centuries of human data. But this vault isn't just sitting there gathering digital dust. The hub operates on a strict time to lean, time to clean logic. See, in normal terrestrial data centers, having idle servers is just a financial loss. Down here, they actually mandate a 100% computational duty cycle. By decoupling the data's identity from the workload, the system instantly absorbs Tier 1 real-time AI workloads from orbit. And if a farm is ever momentarily idle, it immediately pivots to background tasks, like 5x erasure scrubbing. You might ask, why? Because maintaining a constant 100% thermal profile is strictly required. It prevents the microscopic material contraction and stress fracturing that would otherwise destroy the hardware over long time horizons.
Section 4. Nuclear power and laser mesh. Keeping that 100% duty cycle going requires some extreme systems to power and connect this monolithic structure, emphasizing the strict physical separation of volatile energy from the fragile silicon.
Now, what's really interesting about this slide is the extreme longevity strategy they're applying to the power grid. Power is generated by 3,600 small modular reactors, or SMRs. But instead of running a few of them at 100% capacity for a standard 20-year lifespan, they run all 3,600 of them simultaneously, but throttled way down to just 43% capacity. This load sharing drastically slows down neutron embrittlement, which effectively doubles or even quadruples their lifespan to 80 years. Meanwhile, back over at the compute sector, the racks holding the blocks are built from G10 Garolite. That's an aerospace-grade fiberglass epoxy laminate. It basically acts as a thermal brick wall, stopping heat from conducting through the rack. Using passive micro-tilt gimbals, the blocks are staggered in this louvered aerodynamic framework. It perfectly slices those 150-mile-per-hour katabatic winds, stripping away all that exhaust heat completely passively. And how does this massive array actually communicate? Well, there are no central routers. Instead, they use a 3D torus free space optics mesh. They embed microscopic 1550 nanometer infrared laser transceivers into all 6 faces of every block. Data literally shoots through the freezing air as light, which, by the way, is actually 30% faster than traveling through fiber optic glass. And if there's diamond dust, those tiny microscopic ice crystals in the air, adaptive optics just widen the beam to bend the light right around the ice flakes. It creates this beautiful, self-healing mesh that operates at light speed. Section 5, airships and robot hives. Now we have to talk logistics, because there is one absolute constraint here. No humans are allowed in the cryogenic zone. This brings us to the LEGO directive. Think about it. Human life support means pressurized, heated habitats and oxygen logistics. In this environment, a human habitat would introduce a catastrophic thermal plume right into the permafrost, literally melting the structural foundation out from under those 40-ton nuclear reactors. So, as a pure thermodynamic necessity, every single component is modular, standardized, and manipulated exclusively by autonomous machines. Getting parts to the site relies on a massive fleet of fully autonomous hydrogen-electric drone airships. They launch from a megafactory in Portland, Australia, and fly the 3,525 miles to the plateau over roughly 40 hours. But here's the kicker. They never actually touch the ice. They hover using electric ducted fans, drop 144 compute blocks or a single 40-ton reactor directly into waiting cradles using a Skycrane winch in under 10 minutes, and then immediately head back home. Down on the ice, maintenance is a perfectly choreographed ballet of 300 track-driven robots. And importantly, they use zero hydraulics, because hydraulic fluid would just freeze solid. When a block fails during the pitch-black polar winter, a tag team swap happens. It is so fast. Robot A drives down the 20-foot aisle, extracts the 2,420-pound defective block, and clears the lane. Instantly, Robot B slides a fresh spare right into the slot. The total physical exposure to the elements, under 20 minutes. Section 6, the black box of civilization. We've seen the micro and the macro. Let's anchor all of this extreme engineering back to the absolute survival of humanity's accumulated knowledge. So, the crucial point is, this facility is completely immune to terrestrial disasters. Say there's a catastrophic Yellowstone super eruption that chokes out global power grids with ash, the hub wouldn't care at all. It's isolated by the southern polar vortex, and the blocks are sealed in aluminum with zero air intakes. Actually, a volcanic winter would significantly lower global temperatures. That increases the thermal delta between the reactors and the outside air, which would literally boost the SMR's Carnot efficiency by 15 to 25%. Basically, the worse it gets for us, the better the hub performs. But what about the ice itself, right? The Antarctic Plateau accumulates a small snowpack annually, and the glacier slowly drifts horizontally, while the hub literally surfs the glacier. They use a static additive pole system. Robotic crawlers are constantly adding G10 pole extensions to the scaffolding, physically sliding the entire array higher. Over centuries of operation, the facility naturally climbs upward as the ancient ice flows, leaving its original foundations entombed deep below as immovable anchors. Let me read this piece of the final assessment for you. The hub is engineered not merely to survive its environment, but to master it. It stands as an immortal, self-healing black box for human civilization. This absolute commitment to purity is exactly why the architects ultimately canceled the planned on-ice nuclear reprocessing plant. To keep the zone completely pristine, they opted for an Australian battery swap model instead, flying spent 40-ton reactors all the way back across the ocean. Zero compromises. As we wrap up this explainer, we are looking at a blueprint for a fully autonomous, triple-redundant neural network designed to outlast us. So, how will this immortal, self-healing system surf the glacier into the next millennium, and what will it actually learn while we sleep? It really makes you wonder about the digital legacy we are leaving behind. Thank you so much for exploring this awe-inspiring architecture with me today.